So moving on to the next line, we have Pokemon Mewtwo equals Pokemon Mew times 2. So we first look up what Pokemon Mew is, which is 151. And now Pokemon Mewtwo is going to be set to 151 times 2, which is going to be 302. Okay, so now we're going to add Mewtwo mapped to 302 into our dictionary. So I'm going to copy our dictionary from the previous line, and oops, let me erase this to make more space, and try to fit it in somewhere. Alright, going to have Mewtwo mapped to 302. Alright, and that is our dictionary after the change. So our last line of this problem is going to try to set this list with fire type and flying in it to 146. So we're going to try to add that mapping. But if you try this out in the Python interpreter, it's going to give you an error. And this error will be called error unhashable type. And we don't expect you to understand what it means by unhashable type. But basically, this error represents a kind of error that has to do with the immutability of keys in dictionaries. So as we said earlier, dictionary keys must be immutable, which means they must belong to this category over here. And they cannot be in the mutable category, which includes lists and dictionaries. So we can have integers, floats, booleans, strings, tuples, and so on and so forth as keys. But if we try to use a list as a key, it's going to give us this unhashable type error. And so what this error really means is that cannot use list / dictionary as key. Alright. And what this note over here is saying is basically explaining that we cannot have mutable data structures as keys. And when we say mutable, this usually means like a list or a dictionary. But one interesting thing to note is that dictionaries can be arbitrarily deep. So if you remember Flatten, the question Flatten from I think Lab 5, you were asked to, given some kind of infinitely nested list, well, not actually infinitely, but it could go on as many times as the input wants. So you could have lists that are like lists like this, or like just keeps on going, nested like seemingly forever, right? And I don't actually know how many red brackets I should put. That looks good enough. So you could have a list that looks like this, right? Well, what this is saying over here in this line is basically that you could have a dictionary that looks like this. Like if I say hi, that's the key. It could also be mapped to a dictionary that also has the value, or sorry, the key of hi, and then keeps on going and going and going with a bunch of other dictionaries as the values. So basically a value can be a dictionary, and you could have this nested like behavior as we also saw in lists. Alright, so moving on to our last problem for the dictionary section of this discussion, we have remove all. So given a non-nested dictionary D, we want to write a function that deletes all occurrences of X as a value. Remember that if you try to delete items in any kind of sequence as we're iterating through it, or as you're iterating through it, then this can create a lot of weird behaviors. Generally you don't want to iterate through something and change it at the same time. So let me just write that down. Rule of caution. And this doesn't just go for dictionaries, it's any kind of sequence or any time you're iterating over through something and changing at the same time. Rule of caution, bad idea to iterate over something I'll say sequence actually, and modify it. So this is bad because every single step of the iteration, you're going to be changing something about the sequence. And so the sequence you started with is not going to be the same thing as the sequence that's like in the middle of the loop. And so this can cause all kinds of weird behaviors and not give you the result that you're expecting. So a better idea is to make a copy of something. And you'll see in this case, we're actually going to make a list of keys and then iterate through it. So as an example from a past exam, you can also look at fall 2019, I think the Halloween problem. So we had to make a copy of the candies list because when we iterate through it, we're also going to delete some of the candies or take some of the candies out of the list. And so therefore we want to make a copy because we don't want to delete from the original list, we want to delete from the copy instead. Okay, so let's actually jump into this problem. So what I'm going to do first is look at the docstring. So we have D equals this dictionary where we have 4 mappings, 1 to 2, 2 to 3, 3 to 2, and 4 to 3. So our X that we're going to pass into the call to remove all is going to be 2. So that means we want to delete this one and this one because they both have the value 2. And that's why we get the 2 mappings, 2, 3, 4 to 3 remaining after we call remove all. So the first thing I'm going to do is I'm going to make a list of keys. And I'll call them keys to delete because these are the keys that I want to take out of the mapping because they have the value that we want to remove. So this will be key for key in D. And let me just make this a little bit smaller and to the side. Yeah, I think that's good. If D of key equals X. So what this really means is grab me that key and put it in my list if the value associated with that key is X. So it's the value we want to remove, and therefore we're going to keep that key so that we can iterate through it and delete that. So we're going to say for key and keys to delete, and here we're going to take advantage of that delete syntax that we used. So this one over here, del dictionary key. So we're just going to say del D of key. And that will delete all the keys and or not just the keys, but the mappings of that key to the value we want to delete. And that's it for this problem. So the next video will be on abstract data types.